Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you.
Hello everyone, welcome back to my channel. And today we'll be solving Math AAHL Paper 2 of Timezone C of the May 2025 attempt. So let's get started with the first question. So here we have a triangle ABC, right? So two side lengths and an angle is given to us. Now first we have to find BC, which is this opposite side. Quickly name this triangle. So this angle is A, this angle is C, this angle is B, this side is small a, this side is small b, and this is small c. Now, after this, we have to find BC. BC is A. So we know BC and angle A, so we can use the cosine formula. So cosine A would be B squared plus C squared minus A squared divided by twice BC. Okay. So only A is the unknown here. So I'll plug in the values here. Cosine 116 degrees will be 12 squared plus 7 squared minus A squared divided by 2 times 12 times 7. Now from here, if I quickly plug it in my calculator, I'll get A as 16.33, which is the answer to the first part. Now part B, we have to find angle ACB. And this A is equal to side BC. Now ACB is this angle C, right? Now we know side A and angle A, so we can use the sine formula here in this case. So sine C over small c will be sine A over small a. So sine C over 7 will be sine 116 degrees divided by 16.33. Here I can say sine C would be, if I plug everything in my calculator, it will be 0.3853. And from here, if I do sine inverse answer, I'll get 22.7 degrees. So ECB would be 22.7 degrees. That's the answer to part B. Now moving on to question 2. We have this function fx, which is 2x to the power 4 minus 6x cubed plus bx squared plus qx minus 2. So x minus 1 is a factor, and when we divide fx with x minus 3, I get remainder negative 2. So from here, as x minus 1 is a factor, then I can say x minus 1 equals 0 or x equals 1. So x equals 1 is the solution of this function, right? Or the root of this function. So I can say f of 1 will be equal to 0. If I plug in 1 in this equation, I'll get 2 minus 6 plus p plus q minus 2 equals 0. If I simplify this, I'll get p plus q equals 6. That's my first equation. Second equation is when I divide it with x minus 3, the remainder is negative 2. So if I put x minus 3 equals 0, which is x equals 3. So this statement basically means f of 3 would be equal to negative 2. So now replace x with 3. So 2, 3 to the power of 4 minus 6, 3 cubed plus p 3 squared plus q times 3 minus 2. This will be equal to negative 2. We cancel negative 2 on both sides. And if I simplify, I'll get, so this is 3 to the power of 4 times 2 is 162. This is also 162, 9p plus 3q. So these two will also get cancelled out. And if I divide both sides with 3, I'll get q equals negative 3p. So these two are my solutions. So from here, I have to find p and q. So I'll just place the value of q in the first equation. So p minus 3q, p minus 3p will be equal to 6. Negative 2p is 6. So p would be negative 3. If p is negative 3, q would be minus 3 Yeah, minus 3 times negative 3, so Q becomes 9. So my final answer would be P is negative 3 and Q is 9. Now moving on to question 3. A supermarket analyzes shopping habits of its customers. So number of times X each customer visits the supermarket in a week is given by the distribution. Okay, so first we have to find the value of A. So for this one, we just have to add up all the probabilities and equate it to 1. So 1.5A plus 2A plus 0.281 plus A plus 0.026. The sum would be equal to 1. So 4.5A would be 0.693. So A becomes 0.154. That's the answer to the first part. Now I'll just plug in the values of A to get the actual probabilities. So this will be 0.231, this will be 0.308, and this is 0.154. Mode of X. Mode is basically the value of small x for which you have the highest probability. So of course the highest probability occurs here. So mode is small x equals 2. Part A is done. We have to find the mean of x. For mean, we can use the mean formula. Mean is summation of x times px. So when x is 1, p is 0.231. X is 2, it's 0.308. X is 3, it's 0.281. And X is 4, it's 0.154. X is 5, it's 0.026. Above 5, everything is 0. I don't have to consider that. And if I plug it in my calculator, I'll get 2.436, which I'll round it to 2.44, which is the value of your mean. Next, we have to find variance. The formula for variance would be summation of x squared px minus mean squared. We need to find this x squared px, so summation x squared px, this will be 1 squared times 0.231, 2 squared times 0.308, 3 squared times 0.281, 4 squared times 0.154, and 5 squared times 0.026. And when I plug everything in my calculator, I'll get 7.106. So variance of x would be summation of x squared px, which is 7.106, minus mu squared. Mu squared, it was 2.44. So when I put it in a calculator, I'll get 1.172, which I can approximate it to 1.17. This is the variance for this data set. Now, the manager wants to know why customers come to the supermarket. They survey the first 50 customers to arrive at the supermarket on a particular day. Which of the following best describes a manager sampling method? So this is convenience sampling, because the manager is only surveying the first 50 customers of a specific day. Yeah. So it's not random, it's not stratified, it's not even quota or systematic. It's just convenience. He wants to do it like based on ease. So with this, we are done with question 3. Coming to question 4, we have a circle with center O. We have 3 points ABC. Area of the triangle is 26 centimeters and AOB is 2.51 radius. You have to find the length of arc ACB. ACB, so we have to find this arc length. That means we need this angle theta and we need the radius r. This angle theta can be found easily, but okay, let's start with the radius. So for this triangle, area of triangle AOB, this will be half AB sine theta. So like AO, for any triangle, if you know this side, and the angle theta, area is half R1, R2 sine theta. Right, so here also, this side length is R, this is R, the angle is 2.51 radius. So it's R times R squared sine 2.51 radians. Hmm? This is the expression for area, and I know that this area is equal to 26. So r squared would be 26 times 2 is 52 divided by sine 2.51. If I plug everything in my calculator, I'll get the value of r as 9.38 centimeters. That is the radius of this circle. Now we have to find this angle, alpha. Angle alpha would be 2 pi minus theta because the total angle around a circle is 2 pi. Yeah. So this part is alpha, this part is 2.51. So alpha plus 2.51 would be 2 pi. From here, alpha will be 2 pi minus 2.51. So this approximately becomes 3.773. Now for arc length, the formula is r times alpha. Arc length ECB would be r alpha, which is 9.38 times 3.773, which gives us 35.39 centimeters. And this is the final answer for question 4. Coming to question 5, we have a function 2x plus a whole cube divided by x plus 5 whole squared. So we need to find f dash x first. So f dash x, I'll use, we can either use the product or quotient rule. Let's use the quotient rule only. For quotient rule, the idea is I'll first square the denominator. So x plus 5 whole squared would be x plus 5 to the power of 4. I'm squaring x plus 5 whole squared. Then I differentiate the numerator, keep the denominator constant. If you check, this is the 3 here. Might not be clear. So yeah. So this becomes 3 times 2x plus a, and differentiation of 2x plus a is 2. And the denominator remains constant. Minus. Now the numerator remains constant. And then differentiation of the denominator would be 2 times x plus 5, and differentiation of x plus 5 is 1. This is uh, my situation till now. So I try to take everything common outside. So I can take 2x plus a whole squared common, right? And I can also take an x plus 5 common. When I take these two terms common, I can also take this 2 common. It's the same on both sides. Yeah. I'll get 3 times x plus 5 minus, and then it'll be 2x plus a, x plus 5 to the power of 4. Now I can cancel these two, make it cubed. Okay. So 2 times 2x plus a whole squared. And if I open stuffs in this bracket, 3x plus 15 minus 2x minus a. Now I just have to simplify this bracket and I'll get my answer. So 2 times 2x plus a whole squared. 3x minus 2x is x plus 15 minus a divided by x plus 5 whole cubed. That's the expression for f dash x. Next, when x equals 1, the tangent of the graph f makes 70 degrees to the horizontal, or 70 degrees to the positive x-axis. You have to find the smallest value of x. So f dash 1 will be equal to tan 70. Slope is tan theta, same thing here, which is 2.747. Now, f dash 1, if I place 1 in this equation, I'll get 2 times 2 plus a whole squared. This 1 plus 15 minus a divided by 1 plus 5 cubed. Yeah. This actually becomes 2 times 2 plus a whole squared, and it's 14 minus a divided by 6 cubed, which is 2.747. Now we just have to solve for the smallest value of a from here. Yeah. And if I simplify it a bit more, I'll get this. Now, to solve this, there can be various methods. First is you can expand this, right? And then you can use your solver and directly plug into your solver. Or you can actually graph this. If you graph this equation, so you should graph this one. When you graph this, you'll clearly see three solutions. And what you have to do is you just like calculate the lowest one. Let me show you how it should look like. Small calculation error here. 1 plus 15 would be 16. Subtracted it accidentally. Now this is how you should enter it in your calculator. This is the exact expression that should be entered. And this is how your curve would look like. You might have to play with your window settings a little bit. And then when you solve for the lowest point, you will get this. The smallest value of x is minus 5.698. So E is asking for the smallest value. Oh yes, just the smallest value. So this will be your answer. Done. Now moving on to the next question. You have three vectors. You have to find the expression for A dot C, B dot C, angle. Okay, fine. Let's start with A1. A dot C would be minus 5, 7 dot P negative 6 minus 5P plus 7 times negative 6 minus 5P minus 42. B dot C would be minus 8, 9 dot P minus 6. This will be minus 8 times P plus 9 times minus 6. I'm just multiplying the x terms together, then adding them to the product of the y terms, which will give me minus 8P plus, minus 54. Yeah. So these are my dot products A1 and 2. Now the angle between AC is equal to the angle between BC. So we need to find the magnitudes now. Magnitude of A would be root under negative 5 squared plus 7 squared, which is 25 plus 49, 74. Mod B would be minus 8 squared plus 9 squared, 64 plus 81, root 145. Mod C would be root under P squared plus negative 6 squared, which is root P squared plus 36. Now E dot C can be written as mod A mod C cos theta. B dot C can be written as mod B mod C cos theta. The cos theta would be E dot C over mod A mod C. And here cos theta would be B dot C over mod B mod C. Yeah. Now as angles are equal, I can just equate these two. So A dot C, like, and just say cos theta equals theta mod A mod C, B dot C mod B mod C. From here, first I can multiply like mod C to both sides and get this cancelled. Now A dot C was negative 5P minus 42, mod A is root 74. B dot C is minus 8P minus 54, and mod B is root 144, yeah, root 145. Now, to solve this, I can just multiply root 145 on both sides. And I can do one thing, I can multiply both sides with negative, so all these will become positive. Root 145 over root 74, this will approximately be 1.4. Now if I expand, so yeah, so 8P minus 7P. So if I shift 7P to the other side and 54 to the left side and then flip the equation, I'll get this. So from here, I can say P would be 4.8. And that's it. We just have to find the value of p, which we have successfully found here. That's our answer. The next one, we have two more questions. I think three more questions before section B. Now we need to write the expansion of root 1 by root q minus x squared. Okay, coefficient of x to the power 6 is given. We need to find the value of q. Now the expansion of this thing is given in your data booklet, right? So firstly, I can write 1 by root q minus x squared as 1 by q minus x squared to the power of 1 by 2. And then when I bring it to the numerator, I can write it like this. And then I can take q common to generate a 1 before x squared. So if I take q common, it's q minus 1 by 2, 1 minus x squared over q to the power of negative 1 over 2. Fine. Now 1 minus x squared by q to the power of 1 over 2. We have to find till x to the power 6, right? So that will be basically, so first is x to the power of 0, then x squared, then x to the power of 4, then x to the power of 6. So fourth term, yeah. Now the expansion goes like this. So like it'll be nx, then n times n minus 1 by 2 factorial, yeah. And then n times n minus 1 times n minus 2 by 3 factorial. Is the expansion formula to be exact from the data booklet? Yeah. So this is the first term is 1, yeah. Second term is this, third term is this, yeah. And if I generate the fourth term will have an expression of this. Now, when I write the fourth term, just the coefficient part, or I can maybe write it entirely. This is q to the power of minus 1 by 2 from here times n is minus 1 by 2, so minus 1 by 2 times minus 1 by 2 minus 1 minus 1 by 2 minus 2 divided by 3 factorial, yeah, times minus x squared by q to the power of 3. This is equal to 5120 x to the power of 6. Now we just have to solve for q. So now I expand this thing. What should I get? Minus 1 by 2 times minus 3 by 2 times minus 5 by 2. 3 factorial is 6. This is negative x to the power of 6 divided by q cubed. 5120 x to the power of 6. Now I can make a lot of things here. I can make these two positive. Negative, negative is positive. Same for here. I can cancel x to the power 6 on both sides. And then when I simplify this, so 3 times 5 is 15. 2 cubed is 8. Yeah. And I can take q to the numerator. So q to the power of minus 1 by 2 minus 3. 5120. Q to the power of minus 7 over 2 is 5120 times 6 times 8 over 15. From here, when I solve q, I should get 1 over 16 from my calculator. And that's the answer to question 7. Now the next one, there's a tic-tac-toe competition among the students. So each individual game involves only 2 students, of course. Every student in the scheme is to play every other student twice. So however, Stephen left the class after he played only 7 games, and all other games not involving Stephen were played. By the end of the competition, total of 513 games had been played to determine the number of students that were originally there in the class. So first, we'll assume that the total number of students was n. Now let's say you have 3 players, right? So this player will play 2 games with him and 2 games with him, right? So for 3 players, total number of games played will be 4, yeah, by each student. Similarly, if you have 4 students, yeah, then 2, 2, 2, the total number of games played will be 6. And if you just have 2 students, total number of games played will be 2. Now here, we can make a generalization here. That is, each game, like each student will be playing every other student, right? So he will be facing all the students except him. So n minus one, yeah, n minus one students and two games with each student. So number of games, each student with twice n minus one. And then when I find the total number of games, it will be 2 times n choose 2. So from the population of n, I'll choose 2 people every time and make them play 2 games, which is 2n times n minus 1 divided by 2. It's basically n times n minus 1. Now, the number of games missed by Stefan. So Stefan was supposed to play 2 times n minus 1. Out of them, he only played 7 games. Yeah. So this is the total number of games he missed. 2 times n minus 1 minus 7. Minus 7 because he played 7 games and he missed the rest. So games actually played. These were the number of games that was supposed to be played, n times n minus 1. After them, we'll remove the games which 7 missed. 2 times n minus 1 minus 7. Yeah. N squared minus n minus 2n minus 2 plus 2n minus 2 minus 7 is n squared minus n minus 2n plus 9. When you add, open the negative. And then lastly, yeah, will become n squared minus 3n plus 9. And it's given that total number of games actually played is 513. So this will be equal to 513. So if I just push 513 to the left, it will become negative 504. Now, if I put this in my calculator, I'll get two solutions, n equals 24 and n equals negative 21. Total number of students cannot be negative, so I'll reject this. So n equals 24 would be the total number of students in the class, including Stefan. And that's all about question 8. Now, moving on to question 9. I think, yeah, 9 is the last question of section A. An airplane P is flying over horizontal ground at a constant height of 6 kilometers and traveling at a constant speed. It approaches a highway AV, which is 2 kilometers in length. Fine. Let G be the point directly below the G is x kilometers minus. Viewing angle APB is theta. We have to first show that theta is arc tan x plus 2 by 6 minus arc tan x by 6. Okay, fine. So we just have to find this theta. So let's take this total angle as alpha and this much angle as beta. The total angle is alpha and this much is beta. Basically, theta plus beta should be equal to alpha. Yes. Now, if you look at triangle, this triangle AGP, that is this triangle, tan beta would be opposite over adjacent x over 6. We can write this. From here, beta would be tan inverse x over 6. And if you take this total triangle, this angle is alpha. So tan alpha will be opposite x plus 2 divided by adjacent, which is 6. Yeah, I can write it tan alpha as x plus 2 over 6. Yes. So alpha is tan inverse x plus 2 by 6. Fine. Now, as I said, beta plus theta would be alpha. So theta would be alpha minus beta. Alpha is, or I'll write it in the next line. Tan inverse 6 by 2 minus beta is tan inverse x over 6. Tan inverse arctan is the same thing, so a successfully proven part A. Part B. So when the viewing angle is 0.178 radians, rate at which the viewing angle is changing is 12.5 radians per hour, and the speed of the airplane. Okay, so this looks interesting. It's given that theta is 0.178 and d theta over dt would be 12.5. First, from theta, see what can be done here. So we can find the value of x from this given value of theta. Just have to plug in theta in this equation and solve for x. 0.178 would be tan inverse A minus tan inverse B. I can club them together at tan inverse A minus B. Oh, I made a small mistake here. It's tan inverse x plus 2 over 6. Yeah. Tan inverse A minus B divided by 1 plus AB, x plus 2 by 6 times x by 6. Now, I can take tan on both sides to get rid of this. So tan of 0.178 would be, so x plus 2 by 6 minus x by 6, it will be 2 over 6 divided by 1 plus x squared plus 2x over 36. Yeah. Now tan 0.178 radians would be approximately equal to 0.18. And then if I cross multiply the denominator to this, that will be 36 plus x squared plus 2x divided by 36. And this will be 2 by 6, which is 1 by 3. Now x squared plus 2x plus 36 would be 36 over 3 times 0.18. So if I cancel it, this will be 12 to 0.03, basically 200 over 3. Yeah, add a page here, I guess. X squared plus 2x plus 36 minus 200 over 3 equals 0. So can maybe do one more simplification before putting it in my calculator. 36 times 3 is 108. So it's negative 92 over 3. When I use my calculator to solve this, x squared, coefficient of x squared is 1, coefficient of x is 2. Your C is negative 92 over 3. I got two values of x. X would be 4.627 and x is negative 6.63. So I'll reject the negative value and I'll accept the positive value. This is the value of x for which we are getting this theta. Right? Now I'll take this expression and I'll differentiate this. So theta would be tan inverse x plus 2 over 6 minus tan inverse x over 6. When I do d theta over dt, this would be 1 divided by 1 plus x plus 2 by 6 whole squared. And yeah, differentiation of x plus 6 by 2 would be 1 by 6. And then differentiation of x is dx over dt. Right? And for this one, it will be 1 by 1 plus x by 6 whole squared. Differentiation of x over 6 is 1 by 6 dx over dt. Okay. Now, in this question, they're finding the speed of the airline. Say airplane speed will be dx over dt, change in distance over time. So from here, I know x, I know d theta over dt. I just have to solve for dx. The d theta over dt would be 12.5. I'll just take dx over dt and 1 by 6 common outside. So it'll be 1 by 1 plus x is 4.627. 627 plus 2 by 6 whole squared minus 1 by 1 plus 4.627 by 6 whole squared. Okay, now I'll quickly plug this in my calculator. First one, I'm getting 2.22. And for the second one, I'm getting 1.594, 1.595. The thing is, as this airplane approaches, this AB theta will increase. Okay, that is fine. And here, if I simplify this, 1 divided by 2.22 minus 1 divided by 5.95, 1.595 divided by 6, 12.5. When I multiply this, I get dx over dt as negative 424.91. So basically, speed of the aircraft will be 424.91 kilometers per hour. And that is the final answer of this question. So this was total 9 marks. Okay. Now we'll start with section B. Now we have two athletes, Fiona and Lucy, who compete in a 200-meter race along a straight line. Fiona's velocity is given by this equation, 8.14 t over root t squared plus 0.2. Yeah. And we have to find the value of V1. This is straightforward. So V1 would be, just replace t with 1 in this VT equation. So 8.14 divided by root 1 squared plus 0.2. 8.14 divided by root 1.2, which should give us 7.43 meter per second. Second one, time when Fiona's velocity is 5 meter per second. Just replace v with 5 and solve this equation for t. The 5 would be 8.14 t divided by root t squared plus 0.2. Can maybe simplify this a little bit. Root t squared plus 0.2 would be 8.14 by 5t. Okay. So again, from here I can write this, simplify this a bit, 1.628 t. T squared plus 0.2 would be, if I square the right side, I'll get 2.65 t squared. Yes. So if I bring t squared to the other side, I'll get 1.65 t squared equals 0.2. From here, if I plug it in my calculator, I'll get t as 0.348 seconds, approximately 0.35 seconds will be my answer. That's all about part A. Now moving to part B, we have to find the time when Fiona's acceleration is 4 meter per second squared. So now we have to differentiate this velocity to find the acceleration. So v prime t, again using the quotient rule. I'll just bring this down a bit. So squaring the denominator, I'll get t squared plus 0.2 root t squared plus 0.2 whole squared. Now differentiation of numerator is 8.14. Denominator remains the same. Now the numerator remains the same, and the differentiation of the denominator would be 1 by 2, that is the power, different like root t squared plus 0.2, right? So t squared plus 0.2 to the power of 1 by 2. First, I bring the power to the front, then reduce the power by 1. So this becomes t squared plus 0.2 to the power of negative 1 by 2. And differentiation of t squared is 2t. And cancel these from here. And what I can do is I can multiply both the numerator and denominator with root t squared plus 0.2. So it'll give me 8.14 minus 8.14 times t squared plus 0.2 minus 8.14 t squared divided by, this would be t squared plus 0.2 to the power of 3 by 2. Now, when I open this, I can cancel this out. So this becomes 8.14 times 0.2. So 1.628 divided by t squared plus 0.2 to the power of 3 by 2. This is v prime t, or this is the acceleration at. Now we have to find the time when the acceleration is 4. We have to equate this to 4 and solve for the value of time. By 2. So I can bring this to the front. And 1.628 divided by 4 is 0.407. From here, we can directly solve for t, which gives us 0.59 seconds. Using our calculator, yes. That is part B. Part C, find the limit of Vt as t approaches infinity. Okay. To find limit t tends to infinity Vt. Limit t tends to infinity 8.14 t root t squared plus 0.2. What I'll do here is I'll divide both the numerator and denominator with t. So 8.14 t over t root t squared plus 0.2 over t. I can make the numerator 8.14. I can take the t inside the square root. I can make t squared by t squared plus 0.2 by t squared. So finally, the expression becomes limit t tends to infinity 8.14 t squared cancel out. So 1 plus 0.2 over t squared. 0.2 over t squared. 1 by, it's basically 1 by infinity, right, which is 0. So this thing can be equated to 0. And finally, we'll have the value of 8.14 meter per second. This is Fiona's final velocity at t approaches infinity. Now state a reason why value in part C1 is not valid in context of this question. Because it's a 200-meter race, right? So the race will just be over in some time, right? It won't take infinite time for them to finish the race. They are already at a very good pace. Yeah. You see, Fiona has 5 meter per second within like 0.59 seconds. I mean, not 0.59, yeah, 0.35 seconds within less than a second. So of course, I'll write the reasoning like this. Because she has to cover only 200 meters, which will only take some time. Done. That's all about C2. Now they have also given us the equation for Lucy. Lucy's velocity can be modeled by this equation. Fiona completes the race and crosses the finishing line in front of Lucy. So Fiona finishes first, Lucy finishes second. Find the distance Lucy is from the finishing line when Fiona completes the 200-meter race. Okay, so part D is a bit tricky. You have to first find the expression of distance covered by Fiona, which is integral of Vt dt. Let's take this as S. So S will be integral of 8.14 t over root t squared plus 0.2 dt. Now here we have to substitute. We can just substitute t squared plus 0.2 as some z squared. So if you differentiate both sides, 2t dt would be 2z dz. Cancel out 2's. So t dt on the numerator will be replaced by z dz. And here this will be root c squared. And this is 8.14. So root z squared is z. So 8.14 z dz over z. Cancel these two out. So finally you get 8.14 z plus c. And of course we have to replace this. Wait a second. Yeah. Now we'll replace z with the expression. That is root under t squared plus 0.2 plus c. Now how do I find c? I know that at t equals 0, s equals 0. They are starting the race at t equals 0, of course. So 0 equals 8.14 root 0.2 plus c. C is negative 3.64. The expression The distance covered by Fiona with time is this. The C is negative 3.64. Now, using S equals 200, I have to find how much time it exactly takes for Fiona to complete the race. Yeah. If I shift it to the other side and divide both sides with 8.14, I'll get t squared plus 0.2, approximately as 25.02. Yeah. And from here, I can approximate t as 25. So Fiona approximately finishes the race at 25 seconds. Now we have to find the distance covered by Lucy. So for this, we have to integrate it from 0 to 25, Lucy's velocity, which is 80 over root t squared plus 0.3. Again, I'll make a substitution. I'll say take t squared plus 0.3 as some p squared. So 2t dt would be 2p dp. You cancel the 2's. Now here, our numerator will become 8p dp by root p squared. Now we have to change the limits when t is equal to 0, right? The lower p squared would be 0.3, so root of 0.3 would be 0.548. And when p is 25, 25 squared plus 0.3 would be p squared. From here, p would again approximately be 25. So 0.548, 25. This will be 8p over p, so 8 dp. 8 times 25 minus 5.4, 0.548. Yeah, when I simplify this, I should get 195.616. So now the last thing which we have to do is to find the distance between Lucy and finishing line. When Fiona completes the race, this will be 200 minus 195.616 is 4.384 meters. So that was a pretty close race. With that, we are done with the first question of section B. Now coming to the second one, this is, I think, completely based off statistics. So let's start with the first one. Amanda enters data from surveys into a database. It can be assumed that accuracy of any survey entered is independent of all other surveys entered. From the previous records, it's known that Amanda enters 8% of the surveys inaccurately. On a particular day, Amanda enters data from 50 surveys. Given the probability of that Amanda enters at most 6 surveys inaccurately, so see, Amanda enters 8% surveys inaccurately. So this is a fixed value, right? And the number of trials is also constant, which is 50. So this is a binomial distribution. So for A1, I can write it as X is a binomial distribution, 50, 0.08. We need to first find P of X less than equal to 6. So in our calculator, we'll use binom CDF function. Yeah, binom CDF, number of trials will be 50, probability is 0.08, and n is 50. Wait a second. This will be 50, p is 0.08, and the x value is 6. Now, if I place all these in our calculator, you'll get 0.8981. And that's the answer to E1. Now, coming to the next part. Given that at most 6 surveys were entered, and you find the probability that exactly 4 surveys were entered inequally. So that's conditional probability. The p of x equals 4 and x less than equal to 6. So this will be x equals 4 intersection p of x less than equal to 6 divided by p of x less than equal to 6. Now x equals to 4 exactly lies, like completely lies between x less than equal to 6. So numerator is just x equals 4, the denominator is x less than equal to 6. For the numerator, we'll use binom PDF, right? N is 50, p is 0.06, and then the value of x is 4. When I plug this in, I got 0.203, and the less than equal to 6 we obtained in the previous part. We got this now. Upon simplification, we should get 0.227. That is the answer to A2. So A1 and A2 done. Next, on a different day, Amanda enters data from n surveys. On this day, probability that 6 surveys were entered inaccurately is 0.367. Find the values of n. Okay, for this part, we have to use a trial and error approach. Right. To show you how to exactly do this. So x is binom n comma 0.08, and I know p of x less than equal to 6 is given as how much? 0.367. Now we'll first open binom CDF on our calculators. Yeah, binom CD. So number of trials, as the probability is less, obviously the number of trials will be more. Yeah. So after 60, I'll change trials to 70. P is 0.08, x will be 6. When I paste and solve, I got probability as 0.67. Incorrect. Probability has to be low, so I have to plug in a bigger number. Again, I have to go to binom CDF. Now instead of 70, I'll try 90. When I paste 90, I got 0.413. 0.413 is much close to 0.367. So I can try midway 95 now. So distribution, again, when I go down binom CD, instead of 90, I'll try 95. I got 0.355, which is close, but it is smaller than our value. So I'll just reduce it a little bit more. So when I try 94, I got exactly 0.3667. So when n equals 94, and we got p of x less than equal to 6 as 0.367. So answer would be 94 trials. That's part B. So part C, you have two more men, Bryce and Carmen. They also enter data from surveys into the same database, known that Bryce and Carmen are inaccurate up to 6 and 11%. And again, it's constant, it's not changing. From the surveys assigned to three of them, Amanda enters 55%, Bruce 25%, and Carmen 20%. Probability that a random selected survey is entered inaccurately. Now, solve this. This will be. So Amanda enters 55%. Out of this 55, 8% are incorrect. So this will be 0.55 and 0.08. Now next one is Bryce. Bryce enters 25 out of 25%. Out of them, 6% is inaccurate. So 0.25, 0.06. And then Carmen enters 20%, and out of them, 11% are incorrect. So 0.2 times 11. Yeah, 0.2 times 0.11, sorry. Now, when you plug it in your calculator, you'll get 0.081. That is the total probability of an error to occur. That's C1. Now for C2, the probability that it has been entered by Amanda given that survey was entered inaccurately. So it's P of Amanda bar error, which is probability of Amanda intersection error divided by probability of error. Probability of Amanda making an error is this much, 0.55 times 0.08. So probability of error is 0.081. If I plug it in, I'll get 0.5432. So basically, Amanda makes approximately 54% of all the mistakes. That is part C. Now the last part. Following here, accuracy of Amanda and Bryce work remained the same as did the percentage of surveys entered by each of the three employees. However, Carmen's accuracy had improved, and the probability that she entered a survey inaccurately was now X%. Probability that a randomly selected survey entered inaccurately was now the same as probability of Carmen made an error. So find the value of X. So probability of error is equal to X, and probability that Carmen is making an error is also X. So this will be the equation. So P of error Everything remains the same, just that for carbon it changes. Times x. This will be equal to x. So if I add up everything and shift 0.2x to the other side, I get 0.059 equals 0.80x. From here, x will be 0.07375. And x, if I convert it to percent, it will be 7.375 or 7.38% approximately. So carbon's accuracy has improved from 11% error to 7.38% error. That's it. Now, moving on to our last question, which is, I think, a pretty long question. Fine, so here we have to first integrate x squared minus 5 times e to the power x dx. So if we use the eyelet rule, this is the way we'll differentiate and this is the way we will integrate. So we have one algebraic, one exponential. So exponential has to be integrated, the algebraic has to be differentiated. Okay. So I'll take the algebraic outside, integrate e to the power x dx minus integral. I have to integrate e to the power x dx and simultaneously I have to differentiate x squared minus 5 and then dx here. This will be e to the power x squared minus 5 times. E to the power dx is e to the power x and integral of this is 2x e to the power x dx. And again, we have to integrate this thing. So e to the power x squared minus 5 here, integral 2x e to the power x. So take 2x outside, integral e to the power x dx minus integrate e to the power x dx. I mean, it's a double integral actually. And then we have to differentiate 2x. There will be a dx here. So you can try it out with your own by parts formula. I use this one. So this will be 2x e to the power x minus integral of e to the power x is x and integral differentiation of 2x is 2. So integral of 2 e to the power x dx. Plus twice e to the power x plus c. That is the integral of this expression. Done. Now we have a differential equation x squared minus dy by dx equals x squared minus y minus 5. We solve the differential equation, show that the solution kind of looks like this. Okay. If I rearrange, I can write it like this. So it exactly looks like a linear differential equation. So we'll first find the integrating factor. Integrating factor is e to the power of integral. Coefficient of y is 1. So 1 dx, which is e to the power x. Now for the solution, we can use the formula 1 divided by integrating factor, 1 by e to the power x. Integral of, yeah, integrating factor times x squared plus 5, this x squared plus 5 dx. Yeah, this much. This thing we have solved and this is the solution. So e to the power x squared minus 5 minus 2x e to the power x plus 2 e to the power x plus c. When I open the brackets, I'll get x squared minus 5 minus 2x plus 2 plus c e to the power minus x. So x squared minus 2x, minus 5 plus 2 is minus 3. And then I'll get plus c e to the power minus x, which is y. If you check the value here, x squared minus 2x minus 3, x squared minus 2x minus 3 plus c to the power x, and then plus c to the power minus x. So it exactly matched with the expression here. So that is your answer. Now we have to sketch the curve of a particular solution which passes through the point -3, 2. So, okay. For -3, 2, first I have to find the value of C. If I try to plot it in my calculator, I need C. So 2 equals -3 squared is 9. 2 times -3 is +6 -3. C e to the power of -3 times -3 is 3. From here, e cubed C would be -10. So, yeah, C would be -10 over e cubed. So the expression becomes y equals x squared minus 2x minus 3 plus 10 by e cubed e to the power of -x. So I can further simplify it one step and write it like this. Not plus, this will be minus e to the power -x minus 3. Now, when I plug it in my calculator, I should get a graph like this. And here, if you check, it says we have to identify or label only the coordinates of local maxima and local minima. So first, let's generate this curve on our calculators. So -3 in here. This is the expression we should plug in. This is the graph you should obtain. This would be the coordinates of the maxima. And I'll add another page for minima. Now, our question is to sketch the graph. Okay. So we'll just copy this curve. We'll rise up to a value, then go down, and then go up again. And just mention the points. So the minimum point here is 0.899 approximately, comma, minus 4.192. And the maxima I have shown here, minus 2.698 and then 2.281. So 2.281 minus 2.698. Yes. So that is the answer to part C. Now the last one, which is the trickiest question of this paper. There's a tangent at x equals -3, which is drawn for each of these curves. Considering the curve which passes through the point -3, comma p and the curve which passes through -3, comma q, show that all these tangents, all these tangents intersect at a common point and state its coordinates. So, okay, fine. Now the points are -3, comma p and then -3, comma q. We are drawing tangents at these 2 points. Now slope would be basically in dy by dx, you plug in x and y. So it's first x squared minus y minus 5. The 4 minus p. Similarly for q, or this line slope would be minus v squared minus q minus 5, which is again 4 minus q. Now, well, if I write the equation of tangents, y minus p equals slope x minus x1, so x plus 3. Even for this one, if I write the equation, y minus q equals 4 minus q, x plus 3. Now, we just have to expand both of them. So, when I open the brackets and write them, I'll get these two expressions. This one and this one will become, just everything remains the same, just p becomes q. Now, I can equate these two together and find the value of x. So 4x minus px plus 12 minus 2p. 4x minus qx plus 12 minus 2q. This cancels out. This cancels out. When I shift minus qx to this side, minus px plus qx equals 2p minus 2q. Take negative x common, p minus q. Take 2 common, p minus q. P minus q gets cancelled on both sides, so x is negative 2. That's the x coordinate. Now I'll plug in the x coordinate in any one of the equations. Y equals 4x minus p times negative 2 plus 12 minus 2p. So 4, okay, x is negative 2, right? So I can place it here also. Negative 8 plus 2p plus 12 minus 2p. These two p's get cancelled out, so y becomes 12 minus 8, which is 4. So the coordinates of point of intersection, this will be negative 2 comma 4. So with this, we are done with this paper, and I'll see you all in the next video. Bye-bye.